हेलो स्टूडेंट्स, वेलकम टू लेक्चर सीरीज ऑफ डिजाइन ऑफ ट्रांसमिशन सिस्टम्स। आज हम यूनिट 3B का रोलिंग कॉन्टैक्ट बेरिंग का पार्ट डिस्कस करेंगे। रोलिंग देयर आर टू टाइप्स ऑफ बेरिंग, वन इज रोलिंग कॉन्टैक्ट बेरिंग एंड अनदर इज स्लाइडिंग कॉन्टैक्ट बेरिंग। सो आज हम रोलिंग कॉन्टैक्ट बेरिंग डिस्कस करेंगे। In first we'll see the construction of the rolling contact bearing. The main parts of this rolling contact bearing are inner race. Inner race is a rotating part in which the shaft is press fitted. Along with the shaft, the inner race or inner ring of the bearing is rotating. So inner race is having its diameter that is called as a bore diameter, or it is also equal to shaft diameter. Then outer stationary ring is called as the outer race. So outer race is stationary. It is fitted in the housing. And in between the inner race and the outer race, inner race is rotating and outer race is generally stationary. In between the inner and outer race, the rolling elements such as balls, spherical balls. In case of ball bearing, the spherical balls are inserted into the cage or separator portion. Also cylindrical roller bearings, taper roller bearings, angular contact bearings. These are the types of rolling contact bearings. So outside diameter of the bearing is nothing but this. This is the outside diameter of the bearing, and width of the bearing is denoted by B. So on a rolling contact bearing, the loads on rolling contact bearing are of two types. One is a radial load and another is a axial load. So rolling contact bearings are suitable for high radial load and low axial load. So these two types of loads are coming on the rolling contact bearing. One is a radial load. Radial load acts in a direction perpendicular to the axis of the shaft, and axial load, that is denoted as FA, that acts along the axis, axial or thrust load. So next part is the designation of the bearing. Generally bearings are designated by 4 digits. So each digit indicates a certain type of bearing. So the first number, if it is 6, then it indicates the deep groove ball bearing. So if the bearing designation starts with the number 6, that indicates that it is a deep groove ball bearing. If the first number is 2, then it is self-aligning bearing. If first number is 3, double row angular contact bearing. If the first number starts with 30, 31, 32, then it indicates the taper roller bearing. So in the bearing designation, if the first number is 30, 31, 32, it indicates that it is a type of taper roller bearing. If in the designation first number is NU2, it indicates that it is a cylindrical roller bearing. So first number indicates which type of bearing it is. In the designation, the second number indicates the bearing series. So if the second number is 0, then it indicates that extra light series. Then if number is 2, then it indicates a light series. 3 indicates medium series, and 4 indicates second number. If it is 4, it indicates the heavy series. So for the same diameter or same ID of the bearings may be of extra light series, medium series, or heavy series. Now the last two digit, if the last two digit are 00, then it indicates that the bore diameter is 10 mm. That is the inside diameter of the bearing is 10 mm. If it is 01, then it indicates bore diameter of 12 mm. If it is 02, then it indicates 15 mm bore diameter. If it is 03, then it indicates 17 mm bore diameter. And for 04 onwards, we get the bore diameter by multiplying by 5 to the number. So here, if it is 04 and onwards, so we have to multiply by 5 to that number. So 5 into 4 is 20 mm is the bore diameter of the bearing. So this is the bearing designations. Bearings are designated by 4 digits or 4 numbers, and each number indicates which type of bearing, which type of series, and last 2 digit indicates the what is the bore diameter or inside diameter of the bearing. Now next point is basic static capacity, that is CO. So basic static capacity is nothing but it is a static radial load which corresponds to a permanent deformation at the most heavily stressed contact, which is equal to 0.00001 times of the ball diameter. So basic capacity क्या है? It is a static radial load which produces permanent deformation of 0.3 times not 1 times of the ball or roller diameter in a ball bearing or roller bearing. So that static radial load is denoted as a basic static capacity. Basic static capacity is denoted in its unit is Newton or kilonewton. So for ball bearing, basic static capacity is calculated by this formula kd square z by 5, where k is a constant which depends upon the radii of inner race and the spherical balls, and also it depends on the modulo of elasticity of the ball and race material. So k is constant. It depends on radii of curvature of the inner race and spherical ball or cylindrical roller, and modulus of elasticity of the ball and the race material. And d is nothing but diameter of ball in case of ball bearing. Small d indicates the diameter of the spherical ball in mm. Z indicates the number of spherical balls. So CO is calculated by this formula k into d square z upon 5, where k is constant, d is the diameter of the ball, z is the number of balls in the ball bearing. Now for cylindrical roller bearing, this basic static capacity is given by the equation kdlz by 5, where k is the constant, d is nothing but diameter of the roller, l is nothing but length of the roller, z is the number of rollers in a cylindrical roller bearing. Now next is equivalent static load. Equivalent static load is nothing but it is imaginary static radial load, which if applied would cause the same total permanent deformation as that of the actual combined loading. So we know on a rolling contact bearing there are two types of loads acting. One is a radial load, that is Fr, and another is a axial load, Fa. So what is equivalent static load? It is an imaginary radial load which if applied would cause the total permanent deformation as that of the actual combined loading. ये imaginary radial load है, ये जब act होता है rolling contact bearing में, तो same permanent deformation produce करता है as that of the actual combined loading. So equivalent static load is denoted by P naught. It is maximum of these two values. First is xfr plus yfa. Not indicates the static load. So xfr plus yfa, or it is a purely radial load. इन दोनों में से जो ज़्यादा होगा या maximum होगा, that is nothing but equivalent static load, that is P naught. So P naught indicates the equivalent static load. It is imaginary load. इस लोड का इफेक्ट एक्चुअल कंबाइंड लोडिंग जैसा ही रोलिंग कॉन्टैक्ट बेरिंग में होता है. तो इन दोनों में से जो मैक्सिमम वैल्यू है, दैट इज द वैल्यू ऑफ द इक्विवेलेंट स्टैटिक लोड. सो PO is equivalent static load in Newton. F naught R is the static radial load. F naught A is the static axial load. X naught is the static radial load factor. Y naught is the static thrust factor. So for safety of the bearing, the static load capacity of the bearing, static load carrying capacity of the bearing must be greater than or equal to the equivalent static load. इस equivalent static load से bearing का static load carrying capacity हमेशा क्या होना चाहिए, ज़्यादा होना चाहिए, तभी वो bearing उसी वो application के लिए, जो application हम consider कर रहे हैं उसके लिए safe है. So basic static capacity, load carrying capacity CO of the bearing should be greater than or equal to equivalent static load coming on the bearing. Now next point is bearing life. So bearing life of the bearing is defined as total number of revolutions or hours of service at a given constant speed which the bearing can complete before the first evidence of fatigue failure. बेरिंग का फटीग फेल्योर होने के पहले कितने नंबर ऑफ रिवोल्यूशंस बेरिंग कंप्लीट कर पा रहा है विदाउट फटीग फेल्योर, दैट इंडिकेट्स द बेरिंग लाइफ. बेरिंग लाइफ इज एक्सप्रेस्ड इन millions of revolutions, or it is also expressed in hours of service. How many hours of service it offers when it is applied in the application. So bearing life, the bearing life is of two type. It is a rating life, that is the L10 life. So rating life and median life. Rating life is L10 life and median life is L50 life. So what is rating life? Rating life of the bearing is defined as number of revolutions or hours at a given constant speed that 90% of the group of the bearing will complete without evidence of the fatigue failure. बेरिंग का एक ग्रुप है, उसमें से 90% ऑफ द बेरिंग कितने रेवोल्यूशंस या कितने आवर्स कंप्लीट करेंगे विदाउट एविडेंस ऑफ फटीग फेल्योर. फटीग फेल्योर होने के पहले कितने रेवोल्यूशंस वो बेरिंग कंप्लीट करेगा या कितने आवर्स का सर्विस ये बेरिंग कंप्लीट करेगा, 90% ऑफ द बेरिंग कंप्लीट करेगा, दैट इंडिकेट्स द L10 लाइफ और रेटिंग लाइफ ऑफ द बेरिंग. सो नंबर ऑफ रेवोल्यूशंस और आवर्स that 90% of the group of identical bearings will complete without first evidence of fatigue failure. That is known as a rating life or L10 life of the bearing. So L10 life is in millions of revolutions, and it is also expressed in hours of service. Now second life is a median life. It is also called as the L50 life. So L50 life or median life is defined as number of revolutions or hours of service that 50% of the group of the bearings will complete before the first evidence of the fatigue failure. जितने बेरिंग हैं उसमें से 50% बेरिंग कितने रेवोल्यूशंस या कितने आवर्स का सर्विस कंप्लीट करेंगे before the first evidence of fatigue failure. That life is called as a median life or L50 life of the bearing. So bearing life is L10 life and L50 life. So after bearing life, the next point is basic dynamic capacity. It is also called as the basic dynamic load rating of the bearing, and generally it is denoted by C, capital C letter. So basic dynamic capacity of the bearing is defined as a constant radial load which a group of apparently identical bearings can withstand for a rating life of 1 million revolutions of the inner race. Basic dynamic capacity क्या है? It is a constant radial load that a group of apparently identical bearings can withstand for a rating life of 1 million revolutions. 1 million rating life कितना रेडियल लोड बेरिंग ले सकता है फॉर रेटिंग लाइफ ऑफ 1 million revolutions. That indicates the basic dynamic capacity of the bearing. So manufacturer's catalog gives the value of this dynamic capacity of the bearing. So bearing में ये dynamic capacity important होता है, कितना रेडियल लोड वो बेरिंग ले सकता है फॉर rating life of 1 million revolutions. 1 million means 10⁶ revolutions. कितना लोड ले सकता है, that indicates the basic dynamic capacity of the bearing, and it is denoted by letter C. So next point is equivalent dynamic load, that is denoted as a PE. So what is equivalent dynamic load? It is defined as imaginary constant radial load which if applied on the bearing would give the same bearing life as that of the applied combined loading. Equivalent dynamic load is nothing but it is an imaginary constant radial load which if applied on the bearing would give the same bearing life, same rating life as that of the actual combined loading. हमने देखा रोलिंग कॉन्टैक्ट बेरिंग में दो टाइप के लोड होते हैं, एक रेडियल लोड होता है और दूसरा होता है एक्सियल लोड, कंबाइंड लोडिंग बोलते हैं. कंबाइंड लोडिंग में बेरिंग जितना रेडियल लोड ले रहा है, जितना बेरिंग लाइफ कंप्लीट कर रहा है, उसका equivalent radial load. So equivalent dynamic load is nothing but imaginary radial load which if applied on the bearing would give the same bearing life as that of the applied combined loads. So equivalent dynamic load is calculated by PE is equal to XVFR plus YFA whole multiplied by KA. So where PE is nothing but equivalent dynamic load, that is in Newton or kilonewton. X is nothing but radial load factor. V is the rotation factor. V is equal to 1 for inner race rotating. In most of the bearing, inner race is the rotating part, outer race is stationary. So in most of the bearing, V is equal to 1. So V is equal to 1 for inner race rotating. If outer race is rotating, then V is equal to 1.2. And also V is equal to 1 for self-aligning bearing. FR is nothing but radial load, that is in Newton or kilonewton. FA is the axial or thrust load on the bearing, that is in Newton or kilonewton. KA is nothing but it is application factor or load factor. It is also called as a service factor. So KA is nothing but load factor or application factor. So equivalent dynamic load is calculated by this formula. PE is equal to XVFR plus YFA into KA. Where equivalent dynamic load is nothing but it is a combination of radial and axial load multiplied by radial and axial load factors. X and Y are the radial and axial load factors, and V is the rotation factor. For inner race rotating, V is equal to 1. For outer race rotating, V is equal to 1.2. So this is about equivalent dynamic load of the bearing. Now next is load life relationship. So L10 is nothing but rating life of the bearing. the life that 90% of the bearing will complete before the first evidence of the fatigue failure is a L10 life, or it is also called as a rating life. So L10 is equal to C, that is the basic dynamic capacity of the bearing, C upon equivalent dynamic load, C upon equivalent dynamic load raised to A, where C is the basic dynamic capacity or basic dynamic load carrying capacity of the bearing, that is in Newton or kilonewton, and PE is nothing but equivalent dynamic load acting on the bearing, that is in Newton or kilonewton. A, small a is a constant. For ball bearing, A is equal to 3, and for roller bearings, A is equal to 10 by 3. So this is the relationship between L10 life. L10 is equal to C upon PE raised to small a. So this is the relationship between load and bearing life. Now bearing life is expressed in millions of revolutions. L10 life is in millions of revolutions, and there is a relation between life of the bearing in millions of revolutions and life of the bearing in hours of service. So L10, that is the life of the bearing in millions of revolution, is equal to 60 into N into LH 10 upon 10 raised to 6. This is the relation between rating life of the bearing in millions of revolutions and the life of the bearing in hours. So L10 life is equal to 60 into N into LH10 upon 10 raised to 6, where L10 is the rating life of the bearing in millions of revolutions, and LH10 is the rating life of the bearing in hours at the same constant speed. N is nothing but the bearing speed in revolutions per minute. So this is about the load life relationship and the relationship between the rating life in millions of revolutions and hours of service. नेक्स्ट हमें डिस्कस करना है सिलेक्शन ऑफ द बेरिंग फ्रॉम द मैन्युफैक्चरर्स कैटलॉग, the procedure for selection of bearing from the manufacturer's catalog. So as per the application, we have to select the suitable bearing for the given applications. So procedures, there is a step-by-step procedure for selection of bearing from the manufacturer's catalog. So very first step is calculate the radial load and axial load acting on the bearing and determine the diameter of shaft which is to be fitted into the bearing. So calculate the radial load, axial load, and the diameter of the shaft. This is very first step. Then second step is select the type of bearing for the given application. Depending upon which type of load, whether it is purely radial load or axial load, purely axial load. So in case of purely axial load, thrust bearings need to be selected, or taper roller bearings, deep groove, angular contact bearings are suitable for carrying the axial load or thrust load. So for high radial load and moderate thrust load, the deep groove ball bearings are suitable. So select which type of bearing is suitable for the given application. This is the second step. Then third step is determine the values of radial load factor and axial load factor. So these values of X and Y we have to choose from the catalogs or from the table. So determine the values of radial load and axial load factors. Generally these values depend upon two ratios. First ratio is axial load upon radial load, FA upon FR, and another ratio is FA upon CO. FA is axial load and CO is the basic static capacity of the bearing. Basic static load carrying capacity of the bearing. So based on this FA upon FR ratio or FA upon CO ratio, we can choose the value of the radial load factor and axial load factor. So this is the third step in the procedure. Now fourth step is selection of bearing is done by trial and error method. So to begin with, a bearing of light series, generally 60. 60 is a light series bearing. So bearing with light series is selected for the given diameter of the shaft. For the given diameter of shaft, we have to begin with the light series. Then we have to check for medium series, and then we have to go for a heavy series. So to begin with, bearing with light series, that is starting with number 60, is selected for the given diameter of the shaft, and value of the static load carrying capacity CO is found from the table or from the manufacturer's catalog. So this is fourth step. Begin with the light series, that is 60 series. Then fifth step is calculate equivalent dynamic load. So equivalent dynamic load is calculated by the formula PE is equal to XVFR plus YFA, and it is also multiplied by KA, that is service factor. So X and Y are the radial load and axial load factors. V is the rotation factor. For inner race rotating, V is equal to 1. So for most of the bearing, V rotation factor is 1. FR and FA are the radial load and axial load acting on the bearing. So in the fifth step, we have to calculate the equivalent dynamic load acting on the bearing. Now, sixth step is make a decision about expected bearing life. बेरिंग कितने आवर्स का सर्विस कंप्लीट करना चाहिए? इट डिपेंड्स ऑन द एप्लीकेशन. फॉर डिफरेंट एप्लीकेशंस डिफरेंट आवर्स ऑफ सर्विस दैट बेरिंग कैन कंप्लीट विदाउट एविडेंस ऑफ द फटीग फेल्योर. सो मेक डिसीजन अबाउट द एक्सपेक्टेड बेरिंग लाइफ इन आवर्स एंड देन एक्सप्रेस द बेरिंग लाइफ फ्रॉम आवर्स टू मिलियंस ऑफ रेवोल्यूशंस. पहले बेरिंग लाइफ कितने आवर्स हमें चाहिए वो हमें डिसाइड करना होगा, और फिर लाइफ ऑफ बेरिंग इन आवर्स नीड टू बी कन्वर्टेड इनटू लाइफ ऑफ द बेरिंग इन मिलियंस ऑफ रेवोल्यूशंस. Then seventh step is calculate the dynamic load capacity of the bearing. So we have the load life relationship. L10 is the rating life of the bearing in millions of revolutions. L10 is equal to C upon PE raised to A, where A is constant. For ball bearing, it is A is equal to 3, and for cylindrical load of bearing, A is equal to 10 by 3. So where C is the dynamic load carrying capacity of the bearing, and PE is nothing but the equivalent dynamic load that is calculated in the fifth step. So from this load life relationship, we can calculate the basic dynamic capacity of the bearing, that is C is equal to equivalent dynamic load multiplied by L10 raised to 1 upon A, where A is equal to 3 for the ball bearing and A is equal to 10 by 3 for the cylindrical roller bearing. So C is equal to PL raised to 1 by A, where PE is nothing but equivalent dynamic load, L10 is nothing but the rating life of the bearing in millions of revolutions, and raised to 1 upon A is the constant whose value is equal to 3 for the ball bearing, and for cylindrical roller bearing A is equal to 10 by 3. So this is the seventh step to calculate the dynamic load capacity of the bearing. बेरिंग हम जो चूज कर रहे हैं उसका डायनेमिक कैपेसिटी रिक्वायर्ड डायनेमिक कैपेसिटी से ज्यादा होना चाहिए. रिक्वायर्ड डायनेमिक कैपेसिटी से जो बेरिंग हम चूज कर रहे हैं उस बेरिंग का कैपेसिटी, लोड कैरिंग कैपेसिटी, डायनेमिक लोड कैरिंग कैपेसिटी ज्यादा होना चाहिए, तभी वो बेरिंग वो एप्लीकेशन के लिए सुटेबल है, अदरवाइज इट इज नॉट सुटेबल. नाउ एट स्टेप इज चेक वेदर द सिलेक्टेड बेरिंग ऑफ सीरीज 60 हैज द रिक्वायर्ड डायनेमिक कैपेसिटी. जो हमने लाइट सीरीज का बेरिंग हमने चूज किया था 60 सीरीज का, उसी बेरिंग का जो डायनेमिक कैपेसिटी है वो हमारे रिक्वायर्ड डायनेमिक कैपेसिटी से, एप्लीकेशन के लिए जितना कैपेसिटी लग रहा है बेरिंग का, उस कैपेसिटी से ज्यादा है या नहीं है चेक करना है. अगर इफ नॉट, सिलेक्ट द बेरिंग ऑफ नेक्स्ट सीरीज. जो लाइट सीरीज का डायनेमिक कैपेसिटी रिक्वायर्ड कैपेसिटी से अगर कम है तो वो लाइट सीरीज बेरिंग उस एप्लीकेशन के लिए सुटेबल नहीं है, तो हमें क्या करना है, वी हैव टू चूज द बेरिंग ऑफ नेक्स्ट सीरीज, दैट इज मीडियम सीरीज. मीडियम सीरीज का भी कैपेसिटी, डायनेमिक कैपेसिटी रिक्वायर्ड कैपेसिटी से अगर कम है तो हमें हेवी सीरीज की तरफ जाना होगा, हेवी सीरीज की तरफ जाना होगा. और इस तरह से गो बैक टू स्टेप नंबर 3 एंड कंटिन्यू. अगर बेरिंग का कैपेसिटी डायनेमिक कैपेसिटी रिक्वायर्ड कैपेसिटी से कम है तो फिर से स्टेप 3 से ये स्टेप्स फिर से हमें कंप्लीट करने होंगे. स्टेप 3 से फिर से हमें ये स्टेप्स कंप्लीट करने होंगे. एक्स वाई का वैल्यू चूज करना होगा, फिर बेरिंग का नेक्स्ट सीरीज से चूज करना होगा, डायनेमिक लोड कैलकुलेट करना होगा, डायनेमिक कैपेसिटी कैलकुलेट करना होगा, और वो डायनेमिक कैपेसिटी रिक्वायर्ड कैपेसिटी से ज्यादा है या नहीं है चेक करके हमें अगले सीरीज में, बेरिंग के अगले सीरीज में जाना है या नहीं है वो हमें डिसाइड करना होगा. इन दिस वे द प्रोसीजर ऑफ सिलेक्शन ऑफ बेरिंग नीड्स टू बी कंटिन्यूड टिल इट सेटिस्फाई द कंडीशन ऑफ dynamic capacity, condition of the required dynamic capacity. Now the last part of this rolling contact bearing is a design for cyclic loads and speeds. So if the total life cycle of the bearing is divided into various elements or in various operations, so in that case the equivalent dynamic load is calculated as root of N1 P1 cube plus N2 P2 cube plus N3 P3 cube upon N1 plus N2 plus N3. So N1, N2, N3, these are the millions of revolutions in different fractions of the work cycle, and PE1, PE2, PE3, these are the equivalent dynamic load acting during the fraction of the work cycles. So equivalent dynamic load for the cyclic load is calculated by this formula. N1 plus N2 plus N3 is nothing but total number of millions of revolutions. तो ये फॉर्मूला हमें यूज करना है. When the load on the bearing is is not of a constant magnitude with respect to time. If the load varies continuously with respect to time, then equivalent dynamic load is calculated as 1 upon n. N is nothing but life of the bearing in millions of revolutions multiplied by integral of PQ with respect to dn raised to 1/3. So इसी फॉर्मूले से इक्विवेलेंट डायनेमिक लोड हमें कैलकुलेट करना होगा और उसके हिसाब से हमें फिर इक्विवेलेंट डायनेमिक लोड कैलकुलेट करने के बाद डायनेमिक लोड कैरिंग कैपेसिटी बेरिंग का कैलकुलेट करना होगा और वो डायनेमिक कैपेसिटी बेरिंग का हमारे रिक्वायर्ड डायनेमिक कैपेसिटी से ज्यादा होना चाहिए. तो इस तरह से हमें बेरिंग का सिलेक्शन करना है. So thank you very much. See you in the next lecture on a problem on a deep groove ball bearing.